Hello and welcome to another tutorial. So this time around I am going to be implementing something known as a service locator. So a service locator is a tool that we can use to further decouple our code. So one of the things when you've got a large code base, you might have a lot of systems. Those systems need to talk to each other, and it's quite common that you might end up needing things like Singleton, stuff like that for it, but it can get tricky then for the order that stuff actually happens in. You can start to get circular dependencies, things like that, and also you end up having to have, in many cases, hard links from one bit of code to another Singleton, things like that. So one of the things that I want to do with the service locator is it allows us to break that. And what we do is things that provide a service can register to say that they provide that service, and then other things can do a search for that. So what it means is everything goes through that service locator to actually be able to track things down. So we initialize it way before everything else, and then it's able to handle managing to do that linking up. So that's what we're going to be building today. I'm also going to, as part of this, because it needs it, I'm going to set up a non-mono behavior based Singleton. Now, for all of this, I'm going to be doing this in the AI behaviors project. So there is in the description, you'll find 3 links. One is a link to the code as it currently is, as I'm about to start this. The other is going to be a link to the code as it is at the end of the project, so you can easily sort of see the particular changes we needed to make there. And the final link is going to be to the completed overall package if you're wanting to grab the AI package. But I'm using the AI one as a basis for this, the reason being that it means I have a really good solid test case for this. And if you're wanting to see how the core of the AI side of things was built, you'll also see that there is a link to that in the description as well. There's a playlist covering all of the parts of this. So let's dive on in. Okay, so with getting this set up, what I'm going to begin with is getting a few things going in terms of with the Singleton side of stuff. So I've already got this common core area where I have a Singleton set up. Now what I'm going to do is a couple of things. So I'm going to create a folder here for singletons. Now this singleton that already exists, this is actually a mono behavior based one. So I'm going to move that here, and I'm going to rename the file. So this is my mono behavior singleton. And then I'm going to create another file, and this is going to be my standalone singleton. Okay, so that's good. So we'll get these set up and running. Now, that file we don't have anymore. And the other thing that I will do is the mono behavior singleton here. I'm going to do a rename. So this is going to change to mono behavior singleton like that. This will change up here to mono behavior singleton, and I just want to do a rename like that. We'll just check that nothing is too grumpy as a result of that. Hopefully it won't be too broken. Okay, so that's good. Nothing's gotten grumpy at us, so that's an excellent spot to be at. Now, there are a couple of modifications and changes I'm going to make to a few things with this. So this is just sort of adding in some additional support, improving a few different things. So one of the things I'm going to do is, because we're going to have a bit of a need at times for bootstrapping these singletons, so I'm going to have a void on bootstrapped. That's just going to give me something where I can easily handle if that's happened and actually do some specific logic for it. I won't always be doing stuff like that, but there might be cases where I need to do this. The other improvement that I'm going to make is going to improve things for when we're in the editor. So I'm going to add in an FUnity editor. That, and we'll just bring in Unity editor. Now the reason for this is I wanted to make a couple of improvements here just to ensure it properly catches and is properly cleaning up. There's a couple of cases where that could fail out. So I'm just going to #FUnity editor. That, and we'll have on enable. Now with that, I'm going to say editor application, and I want to hook for the play mode state changing. And although I don't have the function set up yet, it'll be on play mode changed. And then we'll have a on disable. Don't need to explicitly mark that as private. Now, unsurprisingly, with the on disable, we're going to do the exact reverse of this. So we unhook that, just making sure that it's properly disconnected. Then we'll have our on play mode changed. Now what this function does is this gets in this play mode state change, and it gets the details on what's actually happened with this. So what I want to check is, okay, well, if what's happening, and I can check, okay, is it exiting play mode? So if it's exiting play mode and we still have an instance, then what I'm going to do is set that it's quitting. And then I'm going to do a destroy immediate on the game object. Now that does mean we change this to be a protected set. The main thing that this does is this is going to, actually I don't even need to do protect there because I've already got it. The main thing that this is going to do is it's going to mean that when we go and stop this in the editor, it's going to forcibly properly clean up the actual instance. And also, if we are bootstrapping something, we have something that we can hook there just to make that easy to actually work with. So that's good. So what we can do then is we can set up our standalone singleton. Now this is going to have some similarities in what it actually does. So there is going to be a bit of overlap with it. So I'll bring in the Unity editor stuff. So our standalone singleton. So it's going to follow the same sort of pattern. Standalone singleton, where T has to be a class and it has to be newable. So that's going to be a key part of this. That can be abstract. Now similar to what we did for our mono behavior based one, this is going to have abstract class, standalone singleton, and we're going to have our abstract void initialize, and that I'll make that internal, and then we'll have a public virtual void on bootstrapped, same as what we did for the other one. Now, at a later point, I may end up making a bunch of this into stuff that is using interfaces for it. There's a couple of other singletons I'm likely going to implement, and I want to get those up and running before I do that, just because I'm not certain yet what things I want to put in an interface, what things I want to put in a common class. So that's still to be determined. So, okay, this one, static T, so our usual approach. So our instance is null. We keep track of if we are initializing it, which by default we're not. We also then have our static read-only object, and this is for our instance lock. This is just to ensure that it's a bit safer for if we're working with this in a multi-threaded setup. So then we have our usual logic. We have our get. Now, this is where we do our lock on that instance lock, and we do all of our code that needs to be thread safe in here. So if instance is not equal to null, then we can actually just return it like that. So it already exists. So our instance is already found. If it's not, then we are initializing it. So what we're going to do is set that to true, create our new instance of T. So instance is our new of T. That's why we had it that this is newable. Then what we do is instance as standalone singleton. So we can cast it like that, and we run our initialize function. Then initializing can go to false, and we can just return the instance. So that's good. So far, so good. Now, with this, we really don't have too much else that we need to sort of set up. Now, this is something where in our mono behavior 1, I do have this construct if needed, and it would run it in a wake. I don't really at this stage have a need for that same process in our standalone one because we don't have any automatic running functions like that. But it could be useful. So what I'm going to do is I am going to bring it across just because it is the kind of thing that we could potentially have a use for it. So just to make it that it's there for any child singletons, I'm going to just have this sort of set up. Now with this, we can't actually destroy particular one because it doesn't have a game object attached to it. So in this case, we found duplicate, and that's about as much as we can actually do because we don't have that mono behavior or game object, any of those things that we can access, unfortunately. Now, what we can do is we can then also set up some stuff here specifically for handling, this initialized and so forth. So that we've got some of those common events there that we might need to actually have. So what I would have is my internal override and the initialize. And what I'm going to do is, oops, not that. So F Unity editor, and then this will have ndef. So similar to what I did with the other one, I will have that editor application, play mode state changed, plus equals, and are on play mode changed. So that's good. Then what it will do is it will run on initialize this, which our on initialize will be a protected virtual void on initialize, like that. So it doesn't need to do anything. We're just making sure that it actually has something that is going to get run there. Now that looks good. So what I would also then do is another Unity editor. Now this is going to be very similar to our play mode changed. The logic here is going to be quite similar. Now, if we think about this, we, at this point, can do the minus equals. So we can do the minus equals. Now it's all within a hashtag funity editor, so we don't need to do anything extra there. Now we don't have the quitting flag because we don't have a way of easily sort of detecting that. What I can do is set the instance, however, to null. One of the things with when it's happening in the editor is we might want to specifically do some cleanup. Now the mono behavior one, there is on destroy that it could actually be hooking for doing that cleanup. With this, we could set up an on destroy. So, but this is one that would only run in the editor. So what I'm going to do is we'll set the function up here, and this will be on editor, or on play in editor stopped, like that. So just to make it super clear that this is something that is not going to be running in anything else. And I will actually move it down so that it is within that hashtag Unity editor. So, okay, that's good. We've got our standalone singleton. We've got our mono behavior singleton. Those are up and running and ready for us to make use of. Now what I want to do is set up our actual service locator. So what I'm going to do is in my common core here, I'm going to create a new folder. This is going to be Service Locator. And then what I will do is create a script. It's going to be the interface that'll be iLocatable service. And then we will set up the actual service locator itself. Locator. So that's good. So let's get these two up and running. Now the locatable service is actually ridiculously simple because it's going to actually intentionally have nothing in it. At this stage, there hasn't been anything that I've needed the locatable service to forcibly implement. It's something that the reason I have gone for an interface is it does make it very easy to make anything locatable. So that's been really handy, and that's something I very much wanted to preserve. There might be stuff in the future where I want it to have a name, something like of that. But at this stage, there hasn't been anything there. So then let's get to the actual service locator itself, because this is sort of the bigger section that we need to get up and running. So we're going to get rid of those. Now the service locator itself is going to be our standalone singleton of our service locator. The other thing I'm going to do, and I'm going to set this up right at the bottom, is I'm going to have a public static class service locator bootstrapper. So the idea behind this is going to forcibly create that service locator, because it's not a mono behavior. It can't be just placed in a scene. So I need something to forcibly create it. And the handy thing with that is I'm going to say runtime initialize on load method, and we have a lot of different ones that we can put here. So I'm actually going to put it as before splash screen, so earlier than anything else. This is something where every other singleton should then make sure it's initialized after this point. So we have our initialize, and all this is going to do is f service locator dot instance is not equal to null. Now that alone will actually instantiate it, but just in case there's particular logic I want it to do, I'm going to invoke that bootstrap method. So that will ensure that the service locator is created. So now in terms of locating the services, there are going to be some things that are global, various manager ones, but there might also be ones that are local to the particular game object that something's on. And get component can be used, but get component is not always the fastest. And certainly something where it's a registry, a lookup-based system is going to be faster. Okay, I want to be able to potentially find stuff in either one, or be able to lock it to particular ones. So what I'm going to do is have a public enum eService search mode, and then we'll have global only, local only, global first, or local first. And this is just defining the different ways that it can actually search for a particular service. So that's good. So when we are looking for a service, it's got to find it essentially with an address. So a global one needs to be able to be distinguished from a local one, and different local ones need to be able to be distinguished. So I want to actually have a context essentially that it's operating in. So what I'm going to do is I'm going to set up a class here. And this is going to be a service address. So this will have a public system.type, service type, and then we'll have a public system.object. And then this is going to be the context. So for a global one, that context would be null. And for a local one, that context might be a mono behavior. It might be a game object. It's going to depend based upon the particular one. I didn't want to dictate from the beginning exactly which one it's going to be. So then we're going to have a service registry here. So this service registry is going to link from our service address to a locatable service. So this is our service registry. That's good. Now, when we go and look for a service, there are two ways that this could happen. A service might have already been registered, and then the thing that is looking for it can just find it immediately. Or something could be looking for a service, and then that service now gets registered, and then it needs to be let know. So we need to be able to have these pending queries. So I'm going to also create a class here. And this is going to be, so the idea is this is a pending service query. So this will be a service query. And this will have a public system type. It's the type of one it's looking for. Now I could put this as a specific address that it's looking for. So I could have a public service address like that. There will be an action that provides a locatable service, and this is the fallback function for when it is succeeded. And then that also needs to be public, and then I will put the search mode here as well. So eService search mode, and this is going to be search mode. So this allows us to define queries that we're waiting on. So I'm going to have a list of service queries, and this is my pending queries. So, okay, let's start to look at how things like registration, stuff like that might work. And then we can look at setting up the actual searching logic. So what I'm going to do is, okay, we'll have a public static void register service T. T is the service that we're registering. We have system object, and this is our context, which default will be null, because a lot of services might actually be global ones. And then what we would say is where T has to be a class, and it has to implement a locatable service. So that's good. That's what our register service function would look like. Now that's the static one. I'm going to then have an internal one of this. This will be register service internal. So what this will do is if our instance is not equal to null, then we just do our register service internal on our instance, and we just pass in all of the exact same things we already had, like that. Now, when it's actually going and registering one, that's something where I need to turn this service and context into an address. Now, an address could already exist, so I want to actually set up a little bit of a helper. So service address, and this will do a find or create address for a T, where T is our in service, and we provide that same context like this. Now we don't need to give it the default of null there, and this is going to be the same requirements. So, okay, what this needs to do is firstly check, okay, do we have any entries for this one defined? So we're going to loop through key value pair, actually, sorry, our addresses in our service registry keys. And then what I want to check is, okay, F, and we'll actually call this address, not addresses. So F, for an address to actually match, well, the context has to be the same. So its context has to be the same as this one. And the type also needs to match. So what we would say is if our address service type, if that is matching type of T that we're running things on. So that looks good. So if it matches, then we just return the address. Otherwise, we actually need to set up a new address. So we would return new service address, and then we want to initialize this. So our service type is our type of T, and we provide the context like that. So that looks good. That will create our service address. So then what we can do here, when we're actually registering the internal one, is firstly, we're going to go service address as our find or create address, like that. I might actually just go var for it. Then what we would do is our registered services, or sorry, service registry address is equal to that service. Now, at this point, we might have pending queries. So I'm going to also have a function here, attempt to flush pending queries, which we'll get to the implementation of that in a moment. But okay, so when we can work with this, we can go through, it'll register a service, and that service has a unique address, has contexts and everything like that that it's operating in. We then want to set up for being able to actually find a service. So this is where we have our actual query. So I'll have static. Now this is going to be explicitly put async in the name because this is running asynchronously. So async locate service T. We provide our callback. And so this is our in callback function. We provide a context that it's looking for it in. Now this I can default to null. So by default, everything will actually look globally. So that means our service search mode in search mode is going to default to global first. And then we do the same as we've done before. T has to be class and a locatable service, like that. Let's bring this so it's a little neater and more on the one screen. So that's good. So that's the static version of this. There will then actually be an internal version of this, similar to what we've had for other ones. So there'll be async locate service internal, like that. And similar to what we did with the register, if instance is not equal to null, we'll just make sure we did not equal, which we did. Then we do instance, async locate service internal, callback function, context, and our search mode. Now with this, we could actually get rid of these defaults because this is an internal function that we're never going to be calling directly. So I won't actually have those. So that looks fine. Why is that grumpy at me? So can't infer from type. So I needed to do that. Easily done. So, okay, now in terms of the location here, so, okay, firstly I need to try and find if this particular service exists. So, although I don't have the function for this, we're going to set it up as if we do have it, just so we know the sort of syntax of what it would look like. So, see if we already have the service. So, we'll do a var result attempt to find service, type of T, with this particular context and with this particular search mode. So if it finds something, so if result is not equal to null, then I would run fallback function with the result and return. If I couldn't find it, then I would add in a pending query. So a new, and so this is a service query. Now, in terms of the information for this, so it needs to be given an address, which that's a service address, and the service type is type of T, the context is our context like that. So it's going to initialize the address. We also need to initialize the search mode and the callback function. So that's good. Now the formatting to stay back is how I had it. Okay, so good so far. At this point, we can actually implement our attempt to flush pending queries because it's going to use this similar logic here. So what I would do is and we're going to process these in reverse order so that I can easily remove ones if I need to. So that's good. Our query is that. Then we go and check, okay, attempt to find the service and run the callback if found. So the idea is that whenever we register, we don't need to continually poll because whenever we register, we're going to rerun this logic to check to see if ones are present. So we do the same sort of logic. The result is an attempt to find service. Then we have our query service type. We have, and actually with this, we could just directly provide the address, but I think because we're not really sort of wanting to have to go and manually create the address here, I think it's fine to not do that. The address is really just sort of serving as the container for it. So we have the query and then the search mode. Then we have the same logic here of if the result is not equal to null, we run the query's callback function with the result. We remove that particular one, and that's done. So that's our query flushing logic. So the big thing then is actually this attempt to find service function. That is actually the one that has most of the logic for this. So attempt to find service. So we know that one of the things it takes is a system.type in type. We know it takes an object for the context, and we know it takes a search mode. So our attempt to find service is really the bulk of the logic, and it is actually a bit more of an involved one because we need to do potentially multiple searches. If we're doing global only or local only, that's straightforward. But if we're doing global first or local first, then we have to search multiple times. So it's a little bit involved in that regard. So what I'm actually going to do is I'm going to set up a helper function. Now this will just be an internal one. So we're going to have a system func, takes in a system type, takes in a system object, and takes in a iLocatable service. And this is our perform search function. So then what this is going to look like, we have our system type in type, we have our system.object in context, and we have our locatable service, and this is our actual return result from it. So we don't do that there. So we're essentially just defining a little lambda function. Now that will default to returning null, but what it will do is it's going to search through our registry entry in our service registry, and then it's going to check, okay, well, the address is our registry entry dot key. So it's going to check, okay, well, if our address and the context for it matches the context that's been provided, and if our address's service type matches that type that's been provided. Now I could, for the address, set up an equality operator. With how infrequently we do this, it's not really a big advantage to sort of setting that up. But if they match, then we return registry entry.value. So this is just a generic search function that goes through the registry, matches the context and the type. So what we can do then is, are we doing any form of global search? So if our search mode is global only, or if our search mode is global first, then what I can do is, okay, try that global search. Try the global search. So we'd say var result, and we do our perform search function. We tell it the particular sort of context that we are looking for it in. So we provide in type, and we provide our context, which, because it's global, is null. So if we found the result, then what I would do is return that result. So, okay, that works for doing the global search. Now, if our actual search was global only, so if our search mode was global only, or if we were not given a context, in other words, we can't actually do a local search, then I have to return null. Otherwise, I try the local search. And this I can just do a direct return. But rather than being null, we provide the context. So global only, or global first, but no context. So that's good. That will work. So, okay, that handles if we're doing a global one. Otherwise, we must be doing some form of local search. So, okay, we can only do a local search if we have a context. Can only do a local search if we have a context. So if our context is valid, then our result, we perform our search function, provide the type, provide the context. If we found something, then we return it. So this is why I set up this perform search function, because we're doing the same logic multiple times, but with slightly different parameters. So it just made it easy to have a local function for it. And then finally, in this case, if we are doing local only, exit. So, okay, if our search mode is local only, there's nothing we can do. Otherwise, try global search. So we do a return, perform search function, in type, and null. So it's a little bit involved, but it does make it easy for us supporting having these searches be run locally, globally, or a mix of both. And then the final one we'll do, just to cover everything, is a return null. So that's the bulk of our logic that we need to do here. We do have our helper functions. So our override, void, so our uninitialize, and one. Now this one needs to be wrapped in our logic for hashif unity editor. Like that. So when we initialize things, service registry, we set that up. And we also set up the pending queries, like that. And then here, service registry becomes null, pending queries becomes null. So not too much that it's needing to actually really sort of do there, which is good. So, okay, that's actually it for the service locator. But let's actually put this to use. And let's address one of the areas that is a problem area for the project, and that is the navigation side of things. So at the moment, we have a navigation interface, which I'll check where I've actually got that put. I think that is here in the Common Core. We've got our navigation interface. So that, what we're going to do is that needs to be something where we can easily sort of locate it. I'm going to put that into its own little folder just to actually have things be a little bit nicer organized. So that's good. So, okay, what we have happen at the moment is our navigation side of things has to go and actually manually sort of be searching for things. So what we have at the moment is our actual system for linking up to navigation. If we take a look at our AI, we have this GOP navigation interface, and there's this binding to all of these things. So what I want to do is I actually want to get rid of that GOP navigation interface entirely. I want to have it be a case that our base navigation system discovers or is discovered, and it goes and actually handles everything. So what I'm going to do is go to our base navigation. And so our base navigation is going to get that it implements iNavigation interface like that. Now it's initially going to be grumpy at me. That's okay, because if we take a look at where our base navigation is, it's in this Framework Essentials. So Framework Essentials, I need to modify the dependencies there so that it has access to Common Core. That's the main thing I need to do there. That will clear that error. And then once it thinks about it. Okay, so we can go and work with this. So I'm going to put Common Core navigation interface like that. Now I could also here just actually using in Common Core, just because we do have a few things that are going to be sort of present for that. Now it's going to be grumpy with things not being implemented. That's completely fine. We will get to that. One of the things that I need to do is I need to register this. So in Awake, what I'm going to do is say, hey, Service Locator, register service. Now it's a navigation interface. We are that service. And the context is going to be a game object. Now our navigation interface doesn't implement locatable service yet. So what I do, because services can say that they implement another service, so that's good. That's our Awake up and running. Now there are going to be things that are not fully implemented in terms of with the interface, and that's okay. We'll get to those. I do want to do one minor bit of sort of renaming of something just to make it a little bit clearer. So I'm going to rename is at destination to our has reached destination, like that. And then what I will do is take all of these over to our base navigation, and then I will implement the support for all of these, and we'll do this at the very end of it, essentially. So these, and this is something where it can be handy to actually specifically comment this. So I might actually do hash region and hash end region. All of these are public. That, so that looks good. Much better. So now I can actually implement the logic for these. Now there's not too much that they actually need to do. So set move location, well, that does a set destination with our destination. Now if that's succeeded, then I set the destination reach threshold to our stopping distance. and return true. Otherwise, I return false. Is pathfinding or moving? Is pretty straightforward. We just return is finding or following path. Has reached destination, similar as well. And so I renamed it because we already have an is at destination variable, so having the function and that match would be a bit of a problem. Stop movement is straightforward. We can say that it always succeeds. So that's good. And then our find nearest navigable location. Well, firstly, we find a position. And that found position, I'm going to default it to our invalid vector3 position. And we do a f find nearest navigable, also find nearest point. We provide our search point. We provide our search range, found position, and if so, then we return found position like that. So that looks good. Otherwise, just to be extra sure, what I'm going to do is return like that. So that's good. Those are our interfaces for it. So what I am now going to do is I want to get rid of the old logic. So I'm going to go to my base AI prefab here, and I am going to get rid of this GOP navigation interface. So that is gone. I'm going to also find the script for it and delete it. Now that is going to make a whole world of things extra grumpy, and that's okay. There's going to be a bunch of things that are probably looking for that and that are not going to be too happy that they don't have it. So at the moment, this would almost certainly not run particularly well. So what I want to do is then find cases of where I was actually using that navigation interface. So one of the ones in our actions, so our action base, we have this navigation here. And I was doing a get component. So this in particular is what I'm replacing. So anywhere that was doing that, we need to update it. So this was the only one at the moment. So how this looks when we're doing the service locator side of things is we do service locator, async locate service. I am looking for a navigation interface. And I want to, when I'm doing this, I provide the callback function first. So iLocatable service in service. So what I would do is say, well, navigation is in service as my navigation interface. Now I want this to search with something that's registered on the game object. So it searches on the game object, and I want it to search actually local only. So that's good. Well, I also want to say here then, if navigation is null, then we return false, because we don't actually have our navigation interface set up and running yet. So we're going to just actually skip out on it. The other thing I'm going to do, just because I think other actions might want to override and provide their own custom stuff, we're going to have a protected virtual bool can action run, and that will just default to returning true. Idea behind this is just other actions might want to do some custom logic for this. So seeing as we're already starting to do this, we might as well set this up now. So if it can't run, we return false, because other ones might have additional services that they want to check. So this is their opportunity to do that. And this happens before it does the cost checking. So this is a quicker test for it to actually be doing. So that's good. That's the action side of things updated. In terms of the Gope brain base, there's nothing really there that we need to update. In terms of any other bits, the main thing that I can also then update is the Gope brain wrapper that we had. So this was in our sample. Now this had a whole bunch of stuff here for the navigation system. We get rid of that. All of that goes away. The entire navigation helpers section, well, that, we don't need it. It's gone. Configure brain, we don't need to have any of that logic there happening. All of that's able to be removed because it happens within the actual logic itself. So I'm going to check and see if anything is grumpy at us. So nothing seems to be overly cranky. So what I can do is let's actually test and make sure that this AI is still able to be moving around. Running. So it's navigating without any issue, and that's with the previous logic all being deleted. If I go to any of my other scenes, so if I go to something like my RTS test scene and run that, you can see they're both moving around. And what it means is the configuration for this ends up being a lot simpler. And that's something that I'm trying to do, is remove things like of this, and there will be future updates where I remove stuff like this, looking at points of interest. I want to essentially remove anywhere where there is a need for doing the actual configuration of what stuff it links to on the actions. I want the content of these actions and goals to be focused on how does it perform this action, not, oh, okay, there's extra stuff I need to link up. So that's sort of big, sort of important changes that I'm planning on making with further stuff there, which is going to make things a lot easier and neater. So that's the core of the changes. We now have our service locator system that we can use for quickly finding services, and we can easily make something a service. So that process to make something a service is very straightforward. It just needs to implement the iLocatable service interface, which has no functions, no properties, anything like of that. So it doesn't introduce any additional stuff. We just need to have it implement that interface. We need to make sure something registers it. And we then also need to make sure that we're then doing that search for it. And that search is asynchronous, so it can happen at any point in time. And we also have our additional singleton for when we've got sort of standalone logic. So stuff that doesn't need to be a mono behavior, it's now able to use that standalone singleton instead. So dive on into the code, do some experimentation with it, see how you go. Thanks folks, hope you found the video interesting and helpful. If you have, chuck in a like and subscribe, really helps out, it's really appreciated. If you have any questions, chuck those in a comment below. If you're looking for the code for the project, that code is linked in the description, as well as a link to the full package and the code at the start of this video. Those are all in there. And if you're looking for other ways to support the channel, then I do have a Patreon, and there is a link to that in the description below. But until next time,